And welcome everybody to the Daily Space Weather, and congratulations on realizing the Smash News Network least busted name in news exists. I'm your host, Dan, aka Smash-A-Mash, bringing you yet another Daily Space Weather video. And you're looking at a coronal mass ejection here. We've seen a decreasing sunspot and flaring activity and an increasing coronal mass ejection activity as forecast. So there you go. You can see there's one full halo eruption right there. And if you're wondering if it's earthly directed, the answer is yes. Now we're going to show you more in-depth information about that toward the end of the video. First, let's go with our regularly scheduled solar imagery. You might see another CME happening up here as the Obama filament erupts, named by one of our viewers on Twitter. Make sure you follow the hashtag #NameThatFilament for your space weather amusement. Yes. So exciting stuff going on. A great example today of how coronal mass ejections do not rely on solar flares or even sunspots. They happen all the time, spontaneously, with basically no warning, like this one right here that you're seeing propagate right at the end of that 24-hour video. Let's go around the horn here. First, we'll take a brief look at the heliographic North Polar region. There you can see that filament saying, whoops, I'm on my way out. So that is now propagating through the solar system. It's just about out of the corona now. We'll show you some closer to real-time imagery of that here. These are all 24-hour videos. There's the northwestern limb, some setting regions there. Here's the southwestern limb. And we're going to keep the pace pretty high today because there's plenty of stuff to cover. We are expecting a coronal mass ejection impact around midday on March 16th. Next, our northeastern limb. Looks like one new active region down there. I don't think it's a sunspot yet. We'll show you high-res imagery of that at the end of the video before we do our meteorology segment. And here is the northeastern limb. That is also a 24-hour video. And you can see some flaring happening there as some of that plasma splashes back down toward the chromosphere. By the way, if you enjoy the content, congratulations on realizing the channel exists. Thanks to our YouTube viewers for tolerating the pathetic and disgusting censorship on the platform, especially over the past 3 years, but over the past existence since Google purchased YouTube back in, 2006? Press like, subscribe, share, etc. Tell your friends and foes about the channel. If you enjoy the content and you'd like to see it continue to exist and remain publicly visible and free for all to view, help out the channel. Do stuff like visit our links and welcome to the Neo-Renaissance. Smashomash.com is the official homepage of the Smash News Network least busted name in news. And thanks for stargazing with us. We're just bringing you the most detailed space weather information and best imagery of the sun you'll find anywhere in the world. One way you can support the channel is by visiting the links below the video. If you're viewing on BitChute, make sure you go subscribe on YouTube. One of the links is to our Redbubble shop. The products will be shown in order of best selling. We just released 4 new products. Today's featured product is Project Management Facts. It can either be expensive, slow, or bad. If your favorite project manager thinks that the project can be fast, cheap, and good, you should fire that project manager, because no project is cheap, fast, and good. It can either be good and fast, but not cheap. It can be good and cheap, but not fast. Or it can be fast and cheap, but not good. So pick 2. Those 3 circles do not overlap 3 ways, creating a mysterious, non-existent project that is fast, cheap, and good. And let's get back to space weather. These videos, by the way, are incredibly expensive. Here is yesterday plus today in SDO intensity gram, and we'll see a further reduction in sunspot number today. We see one evaporating up here. We see some setting up here. So also some sunspots evaporating down here. It's a reduction in solar activity, at least on the Earth-facing portion of the solar disk. Yesterday plus today, here's the colorized magnetogram from the SDO Browse Data section. We're going to take a brief moment to go over what's going on Croissant Earth. So let's look at volcanoes. Abikos exploding, producing a 14,000-foot ash plume. That's an uptick there at Paramushir Island there south of Kamchatka. Subanosejima exploding, flight level 040, 4,000-foot ash plume over Subanosejima. Merapi exploding, uptick there at Merapi, 14,000-foot ash plume. Semeru exploding, flight level 150, 15,000-foot ash plume over East Java. Popocatépetl exploding, flight level 210 over central Mexico. It's a 21,000-foot plume of volcanic ash. Please don't pole vault the caldera. Fuego exploding in Guatemala, flight level 160. Nevado de Ruiz exploding in Colombia, flight level 200. Here's one that's never been on our list before. Cerro Negro de Maya Ascar. And I think the Maya might have been scared of that volcano. Who knows? But there is certainly an earthquake swarm going on recently beneath it. So let's see. Do we have an elevated alert level here? Recent swarm could suggest elevated fluid movements of gas, water, and possibly magma under the surface at Cerro Negro de Maya Ascar. Sangay in Ecuador exploding, flight level 190. It's a 19,000-foot ash plume and 24,000-foot ash plume over Sabancaya. Please don't pole vault the caldera. Next, looking at global seismicity. There's the past 90 days of earthquake activity on planet Earth. And let's take a look at the USGS map here. 2 site quakes over a 5 magnitude. So not as many quakes as yesterday's report. However, we do have some over a 5 magnitude like this 5.1 at the Solomon Islands. And a quick reminder that any earthquake could be a foreshock. Any earthquake could be a foreshock. Have an idea which buildings might collapse. If you are to evacuate yours, don't be under a collapsing one at the moment of the shaken. We also had a 5.2 at Papua New Guinea there. So not a lot of big quakes, not a lot of quakes, period. They are mostly around the Pacific Rim, as you may have come to expect. There was also a 5.0 at Fiji at extreme depth. Estimated depth there over 550 kilometers. And let's get back to space. And I think I may have forgotten to put up some imagery here. Give me a moment. We're moving on to the 10.7 centimeter radio flux, which is down to 150 solar flux units. Let's blast through the space weather data sets. So, here we go. There is SDO imagery in 171 plus 211 angstroms. And the Earth-directed CME came from this area down here. You're barely going to see it. And that's often what happens when it's directed right toward you, the viewer. So here's some more imagery of the North Polar region. Again, radio flux now down to 150 solar flux units. If you're wondering what a solar flux unit is, that is 10,000 joules of radio flux density, discovered in 1947 by some Canadian radio enthusiasts using World War II equipment. That's how the 10.7 centimeter radio flux was discovered. It's the most proportional number that we have to sunspot number. So it's very directly proportional to sunspot number. You can see it dropping here along with the sunspot number. It is coming out of the upper chromosphere and lower corona. Here's a space weather enthusiast dashboard forecasting a little bit of geomagnetic storm conditions on Wednesday, March 15th there from a CME that occurred on the 11th. It's expected to be a glancing blow. I thought that one was a miss. We'll have to see what happens. But in any case, that's the forecast. We are expecting a CME to arrive midday on the 16th from a fairly high-speed CME that we showed to kick off today's video. So let's take a look at some earthly data here. Here is our geospace magnetosphere movie. That's the past 4 hours of magnetohydrodynamic pressure. Things are geomagnetically calm here at the moment. That's Earth to about 12 Earth diameters. Approximately the size of the magnetosphere. Next, ground magnetic perturbations, and things are calm here. We're not going to show other maps, just the global map. Again, it is a geomagnetically calm condition here at the moment. Expecting some upticks here in the coming days. So exciting stuff going on as we approach the spring equinox, and we'll be talking about the Russell-McLaren effect later in the video as well. If you're wondering why March is actually the most geomagnetically active month, we'll briefly explain why and tell you how to read more about it if you like. Planetary K-index on the floor here, only at 0.67. KP there, less than 1. It's a pretty weak solar wind situation. Let's take a look at it. Now, keep in mind that the solar wind needs to be measured outside the magnetosphere. It's measured by the ACE and Discover here at Lagrange 1. Here are the data. Current conditions are about 7 protons per cubic centimeter for the solar wind density, solar wind speed 318 kilometers per second. So it's quite slow here, and the density is kind of nominal. Next are GOES magnetometers. These are measured from geosynchronous orbits near the equator, geosynchronous near equatorial orbits, the GOES 16 and GOES 18. There are the measurements from those. A little bit higher lows there in the past 24 hours. And let's take a look at the heliospheric current sheet next. Now, this data comes from 51 ground-based magnetometers, as well as magnetometers here on stereo A and on stereo B. Earth right now is in the North Pole, so the North Magnetic Pole is the current position of planet Earth. Also, stereo A and stereo B solidly in a North Pole current sheet depicted here in green. Looks like the South Pole current sheet is growing there on the far side of the sun. We'll be keeping you posted on that on tomorrow's video. Next, our line of sight plot. There, the sun's B field is depicted in blue, North Pole in green, South Pole in red. Those are the potential field surface source lines. And let's move to coronal holes. So we've got some North Pole-oriented coronal holes, and we've got some spectacular imagery of that for you. Probably no surprise to our regular viewers. So let's do it. So here's this North Pole-oriented coronal hole here rising in the southeast. A source of high-speed solar winds. Coronal holes are also solar radio jets. They're like low-pressure systems in the solar atmosphere, and stellar low-pressure systems are so low that they blast material out into space. Here's the northern hemisphere. We do have a fairly well-defined coronal hole up here north of the equator as well. And let's zoom out to show you the full disk view. That's 24 hours in SDO 211 angstroms. Which brings us to sunspots, which have been degrading and setting. So we'll have a further decrease in the sunspot number and likely the radio flux today. There is your flare probability and solar flare scoreboard. So a big dip here in the radio flux as well as the sunspot number. Don't expect this ramp down to continue, though. We are still a ways from solar maximum, so get ready because this is a temporary lull in activity, and it's not going to last. We've still got probably over a year until we reach solar maximum, and it's going to be an exciting year on the channel indeed. Here's another 24-hour video. That's SDO 171 angstroms plus the continuum. Let's zoom in a little bit. And let's subtract the 171 angstroms to show you sunspot evolution. So there's a 24-hour video SDO continuum. Significant dip in sunspot number and radio flux to come. So we're expecting the radio flux to drop even further today. And again, there is some plasma headed our way. And let's talk energetic particles, because we did have a solar energetic particle event. Check it out. We had a spike in the proton flux here, causing some minor polar radio blackouts. It was associated with that long-duration C-class flare. That was the eruption of the Barack Obama solar filament. And if you want to follow radio blackouts and so on from solar energetic particle events, you can take a look at it on the deabsorption predictions. you'll see those appear as polar radio blackouts. So the flares will cause equatorial radio blackouts, and the solar energetic particle events will cause polar radio blackouts. So you see that subsiding here. The peak flux was right around 919. As that radiation attenuates the D layer of the ionosphere, causing radio signals to, instead of refracting back down to Earth, get channeled out into space instead. That's your deabsorption regions. And then here's your... Oh, that's a more recent flare. Okay. Oh, wow. Check it out. So let's see. The peak flux here was at 1110. 1110 for that long duration flare. Oh, nice. It's not even really associated with a flare. Check it out. The peak particle flux here happened between 8 o'clock and 9 o'clock universal time for the proton spike. But that wasn't really associated with a flare. So that was just the CME, a great example of how you can have a solar energetic particle event and no flare associated with it. So keep in mind, folks, these things are all separate phenomena. Solar flares are not the same thing as coronal mass ejections, are not the same thing as solar energetic particle events. So it's always interesting to see what correlates and what doesn't. As in the realm of physics, cause and effect really matters. So here's the past 24 hours and one of our favorite flare wavelengths. This is 131 angstroms. Keep in mind, it's not viewing flares per se. It's not X-rays. It's actually extreme ultraviolet. There you can see the Barack Obama filament ejecting there right at the end of the video. Right up there in the north. There it goes. Here's 94 angstroms, the same time frame. That's 24 hours. And thanks for leaving a comment, Mr. Bordages. So let's move on to give ourselves a brief idea of where things are located. This is what's going on overhead Lehigh Valley, Pennsylvania. We've got the moon. We've also got Saturn and Mercury there. Mercury just ahead of the sun. If you're up before sunrise, you may see Saturn and Mercury. Those are the bright objects you're seeing near the ecliptic. Here's a solar system forecast for the next week. So here's where things are today. Keep in mind, this is not to scale. Here's our 1 week forecast as we approach a new moon. And let's take a look at coronal mass ejections. So here's yesterday's imagery. You can see a CME up there in the northeast, as well as one down here in the south. Those will both miss Earth. And then when we look at today's imagery, well, different story. A full halo eruption there. And it looks pretty high speed. That's why we're forecasting it to arrive as early as even early in the day on the 16th. But I would say by midday on the 16th. So Thursday the 16th, we're expecting a geomagnetic storm condition arriving right around when we make our video. So it'll be a great opportunity to check the forecasting on that. NOAA expecting a CME impact on Wednesday, and we're expecting a CME impact on Thursday. Exciting stuff going on. And let's take a look at our view from Stereo A and Soho Lasco C3. So we paused this here at 423 for the Stereo A imagery and 454 for the Soho imagery. And yeah, that is an Earth-directed CME all day. Let's bring those back. Keep in mind they are not the same time frames. Just pay attention to the time and dates. We typically load 90 frames for each of these images. There is some missing data on the Stereo A there. So again, keep note of the time and date stamps down there at the bottom of the screen. There's that halo eruption. That is headed toward your doorstep. So excited about that. Hopefully we'll see some aurora images and so on. Here's a 24-hour video with the SDO 304 angstroms wavelength. That's actually where we started the video out. Let's zoom in a little bit. Mercury there coming into frame in the lower right. And it's another exciting day for space weather. Again, that Earth-directed CME came from this area down here, and you can barely see it. Let's move on here to look at filaments, because we've still got quite a few of them. Now, one of them has left the building. Actually, it's left and splashed back down. You can see right at the end, you can see that bright flash there. That is the Obama filament fully collapsing, the part that did not eject. Bring up the latest image. There's what's going on. We've still got significant filaments. Once again, if you want to name filaments, join us over on Twitter. We're all over the internet at smashomash.com. You can find links, etc. Thanks to our Twitter followers. We're all the way back up to a whopping 390 now after having an account since 2019, original content daily, and 19.3 thousand tweets. As the shadow bans continue because reasons. So there is your 24-hour SDO video. I think we showed that one already. There's the Northern Hemisphere. That's 304 plus 193 angstroms. Oh, wait, we didn't show that yet. So lots of filaments here. Lots of filaments continue to exist on the Earth-facing portion of the solar disk. And just to reiterate, we don't need sunspots or solar flares to see coronal mass ejections. These things are separate phenomenon. Here's one more close-up of that Barack Obama filament ejecting and splashing back down. And here's the last 24 in SDO 304 angstroms. Lots of imagery today because lots of activity kicking off, despite a dip in sunspot number and radio flux. And of course, we painstakingly download all these videos to provide you not only the most comprehensive space weather in the world, but the most detailed solar imagery that you'll find anywhere in the known universe. We knew it would be a lot of work going in. And Solar Max is going to be an exciting time. So we're going to zoom out here for a moment. That's the past about 2.5 hours of 304 angstroms. That's ionized helium, by the way, just like the SDO 304 angstroms wavelength. The GOES 16 SUVI there with its wider field of view. And you could call that a money shot. So let's zoom in a little bit here. There's the full zoom. Let's make sure we get the full extended corona. So exciting stuff going on here. Expect the coronal mass ejections to continue. And let's move to bonus features. So our bonus features are starting out with satellite charging hazards. We ain't got none. It's smooth sailing for satellites at the moment. No surface or internal charging hazards. GOES electron flux here, kind of low. And it's looking like it's right on the forecast. So that's your GOES electron flux measured by the GOES 16 and GOES 18 from their geosynchronous orbits using radiography to measure it at the F layer of the ionosphere. There's our ongoing dip in electron flux. And the NOAA forecast expecting a continued decrease in the relativistic electrons at the F layer of the ionosphere. There's the one-year graph to put that in context from solon.info. If you want to go follow that graph yourself, solon.info is a location. Let's take a look at the vibrational frequency of the F layer as we see significant anomalies, once again, mainly of the high-frequency variety. So this is the previous day. It's showing 2 hours per second on each frame there. Yeah, lots of high-frequency anomalies happening. And if you're not familiar with looking at this data set, don't worry, we'll show the anomalygram as well, which is a little bit more definitive. It shows higher resolution. So fortunately, the anomalygram shows down to 1/10 of a megahertz there. That's anomaly in megahertz from a 30-day median. Also the previous day, and you're going to see lots of blue there on the map. So those are high-frequency ionosphere anomalies. We're expecting some stratospheric warming as we're getting closer and closer to understanding the bridge between Earth and space, as some science is actually progressing in this realm. So anyway, that's what's going on at the bridge between Earth and space. Here's the latest image. That's 12:15 universal time ionogram and 12:15 universal time anomalygram. High-frequency anomalies continuing here. You can see some there at the southern tip of Africa, the Southern Ocean, the South Atlantic, Southern Indian Ocean, and southern South America. Let's talk about the Russell-McLaren effect. So March is actually the most geomagnetically active month of the year, just slightly more geomagnetically effective than October, and it has to do with the angle of attack. So magnetic field lines play a role here. Earth's axial tilt plays a role. And basically the reason is because of the perpendicular angle of attack. So if you want to read about the Russell-McLaren effect, there's a great article on Earth Sky, earthsky.org, Aurora season, why more auroras at the equinox. And basically it's because the outer Van Allen belt electrons get accelerated to a greater extent, and that causes increased ability for electrical current to be created as the solar wind strikes the Earth's magnetosphere. So we're just going to let that scroll there if you want to slow down the video and read the article. But basically what it is it's the angle of attack. So at the equinox, the Earth's axis is roughly perpendicular to the ecliptic plane, which makes it roughly perpendicular to the incoming solar wind, and that creates a bigger hit. So that's the reason for that, the Russell-McLaren effect. It's all about angles. Let's take a look at the total electron content next. Total electron content forecast will show you the most likely places for GPS errors. It's the free electrons from the inner portion of the outer Van Allen belt down to your handset. That's a run of about 12,500 miles. And things are pretty orderly here, despite a fairly low electron flux. So that's an indication that Earth's magnetic fields aren't breaking down in any way. If you think Earth's magnetic fields are going to flip, we think it's a lot more likely that they will just snap back toward the geographic poles. The likelihood of an earthly magnetic reversal is incredibly low, and we've got a long way to go as far as the, quote, weakening of Earth's magnetosphere, end quote, before we reach anything that's critical. Again, we find it a lot more likely, statistically speaking, for Earth's geomagnetic excursion just to end, as opposed to continue on and get more and more extreme and cause a pole flip and a long-term geomagnetic excursion and so forth. Let's move on to our final space weather portion of the video here. This is the latest SDO intensitygram and latest SDO magnetogram, I think. There we go. And let's take a look at this active region down here, as we do see a little bit of activity happening. And that is not yet a sunspot. So a little bit of magnetic field organization happening there. No dark umbra yet visible. It's a tiny active region anyway. Here's your full disk rock back. Again, we've seen a decrease in sunspot area, as well as the radio flux and some setting sunspots in the northwest. So we're going to have a big decline in the sunspot number and the radio flux today. And if you're panicking about that, I feel sorry for you. Consumer tip: stop consuming nonsense on YouTube. People who don't understand astrophysics, cosmology, etc. should not be giving you advice on your bunker depth. Next, we're going to meteorology. But first, if you want to support the content, consider becoming a member of the Smash Team at smashomash.com/Smash Team. You'll get additional content at a gold or silver level especially, and you can even sign up for email alerts. We even send those out to the bronze level, which is, quote, free, end quote. The best value is the gold annual paid-up subscription thanks to our Smash Team members. You are increasing the probability these videos will continue to exist and remain publicly visible and free for all to view. Smashomash.com/Smash Team launched in October 2021 to replace Patreon, although we still are on Patreon. Don't forget to visit the links, like the links to Hemp Lucid and links to all of our other social media accounts and so on. Hemp Lucid products there. Save some cash by entering the promo code SMASHOMASH. Save some cash with the promo code SMASHOMASH, and thanks for leaving a comment. General Disturbance. Quick reminder, we will be streaming at the time of the equinox, so we're less than 8 days here from spring. So we will stream on YouTube here. We'll start at about 5 p.m. Local time on March 20th, Monday, March 20th. So 1 week from today at 5 p.m. we'll do a live stream because we want to be the first person to wish you a happy spring. Winter is almost over, folks. What are you doing with the last week of winter? Let us know in the comments. And let's take a look at wave height. And quick note here, General Disturbance, thanks for leaving a comment. General Disturbance says, after watching Ben, I assume he doesn't mean Ben Shapiro, I am now certain that there are 4 elementary particles: electrons, protons, neutrons, and morons. Many of our viewers would tend to agree. Anyway, we're looking at the Earth's largest waves, as I am a wave chaser. So the animation you're seeing there is surface winds, and the coloration there is wave height. The current highest waves are in the Southern Ocean there, south of Australia, at about 30.8 feet. Those waves aren't that big. The seas are fairly calm here, although we do have some large waves there off the coast of Spain and Portugal there, south of Ireland, also in the North Atlantic there, in between the Azores and Bermuda. Those aren't quite as big as the Southern Ocean waves, though, although they are close, around 30 foot. So let's get to our regularly scheduled meteorology segment. These are the surface winds of the eastern world. What about the jet streams, you ask? Well, there you go. Jet streams of the eastern world depicted here. Jet streams of the western world. Moving right along, we've got a doubled-up jet stream over the western Atlantic and a tripled-up jet stream over parts of North America. Here are the surface winds of this side of the planet. Central world, surface winds are looking like this. And these are the jet streams like sands through the hourglass of time. These are the jet streams of our lives. Next, looking at clouds and fog over the Americas. So that's what's going on Crescent Earth. Our clouds and fog view, courtesy of the NASA Interactive Weather Satellite Suite, the NASA GOES Interactive Weather Satellite Suite. That's a 3.9 nanometer infrared radiation map showing clouds and fog when it's too dark to use the visible satellite over most of the map. Next, our weather.gov map. If your location's lit, click your locations. We've got some hard freeze warnings over large portions of the southeastern U.S., so be aware of that. Get your early plantings covered and so forth. If your location's lit, click your location on weather.gov, and some flood warnings continuing for California. So let's take a look at temperature anomaly forecasts first. This is your GFS 72-hour temperature anomaly forecast in degrees Celsius, and you can see that cold air moving in to the southeastern U.S. And a bunch of hot air over here. Check it out, folks. It's the hot air capital of the country, Colorado. Colorado, the C, it stands for charlatans, as there are plenty of them there, actively misrepresenting science to their viewers, pretending that they are science in a Fauci-esque disinformation pile of crap. Colorado, if somebody's trying to convince you to move there, maybe think again. Their science might be flawed. Because if you're ossified in your beliefs, folks, you're not doing science. Next, our pressure and precipitation forecast, and check out the heavy precipitation they're coming to California. That is suboptimal. Oh, it just keeps getting pumped in and pumped in and pumped in from the Pacific Ocean. Of course, we have some equatorial warming of the Pacific Ocean at the moment, which means additional evaporation, perhaps no end in sight, as California gets wetter and wetter. Here's your GFS 72-hour positive accumulated snow depth change in inches forecast. And there are some spots there in California that are expecting another 3 feet of snow or so. 2 to 3 feet in large portions of California once again, and also some snow coming to the northeast, also the northern Rockies. Let's show the difference between the GFS and the Euro forecast. There's the Euro forecast for new snow over the next 3 days. And there is the GFS forecast. Let's look at rain accumulation here real quick. There's the next 3 days of rain accumulation for the GFS model, and there is the Euro model. And let's take a brief look at California here. DAG. Expecting over 5 inches, over 4 inches, etc. GFS model not calling for quite as much rain in the northern portion. So there's the Euro model for rain accumulation, and there is the GFS model. That's windy.com, by the way. They got a great free mobile app. Feel free to install that. It's got all kinds of features that you might find intoxicating. Next, our lightning mapper. And it looks like Florida was the lightning capital of the U.S. in the past about 10 hours. Let's see if we have any active strikes here. We did have some when we did show prep. Southwest of Tallahassee there. Some active cells there in the Gulf, and also off the coast of Daytona Beach. Perhaps some quality waves rolling in there on Daytona Beach. And you might get some great views of those. Make sure you take some videos of the cloud tops if you're... Oh, check it out. We just had some strikes there right on the beach. New Smyrna. There's thunder rolling in. Daytona Beach. All right. Anyway, here's your full Earth map from lightningmaps.org. We're not paid to say that. Although, maybe we need that organization on our cycling jerseys. All right. Let's continue on here to close this thing out. Here's your U.S. Doppler radar map. You can see a bunch of precipitation there around the Great Lakes and also in the Pacific Northwest mainly. Also Houston looks like it's in the crosshairs for some precipitation. Houston, there's precipitation rolling in. So that's Doppler radar. Here is infrared radiation at 3.9 nanometers, showing clouds and fog. And last but not least, there is the water vapor map. So we do have a pocket of cold air here blasting down from Canada. And that's going to provide an impulse here. So as this turns a little bit to the east, that's going to push weather systems through. Although this low is expected to hang out right around Cape Cod. So it's going to loiter for a bit. That is the forecast. Here's your recap. U.S. Doppler radar. Clouds and fog. And water vapor. Thanks for tuning into the Smash News Network, least busted name in news. We like to cite facts and keep the videos dense. We hope our viewers are dense also, as dense brains are associated with high IQs. Anyway, we'll see you soon. Thanks for tuning in. Congratulations once again on realizing the channel exists. In the meantime, I've been your host, Dan, a.k.a. Smash-A-Mash, signing off. And may that solar wind be at your back.